Alright guys, welcome back to Underground Science, and in this video we're going to be practicing alkyne naming, and this is going to be part 2. So let's dive into an example right away. Alright, so this example we're going to be dealing with 2 triple bonds. Again, same thing, you number it so that both the triple bonds are on the least carbon number. So if we started from the right side, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? But if you started from the left side, you'd get 1, 2, 3, 4, 5, 6, 7, and we don't have to keep on going because all we have to focus on, actually we should go a little bit more, just till here. Go and write this down for the red numbering pattern, right? At what carbon numbers do the triple bonds fall on? That would be carbon numbers 4 and 7. And for the blue numbering pattern, at what carbon numbers do the triple bonds fall on? That would be carbon numbers 5 and carbon number 8. So is 4 and 7 less than 5 and 8? And the answer is yes. So we would choose the red numbering pattern and not the blue numbering pattern. All right, so this is the correct numbering pattern. Knowing this, we can name the molecule. So at what carbon numbers do we have the triple bond at? That would be 4 and 7. So it'd be 4, and we don't have any substituents, so we just have to deal with the triple bonds. It'd be 4, 7. And how long is this carbon chain? That'd be 12. So it'd be dodeca, right? Dodeca. But we have 2 triple bonds. So that would be dodeca, di. And then we have triple bonds, not double bonds. So it'd be di and the suffix "-ine". The full name of this molecule would be 4,7-dodecadiene. Now this is correct in terms of IUPAC rules, but remember, you can also write it like this. Dodeca, and then specify where the triple bonds are right here instead of the beginning. So it'd be 4, 7, and then you finish off the name by saying diene. So these two are 2 correct ways in terms of IUPAC rules in which to write the name of this molecule above. Moving on to the next example, let's do the same thing and number the longest carbon chain. But now if you notice, we're dealing with a molecule that's an alkene and an alkyne, right? It consists of both of those functional groups. So let's say we start numbering from the left. It'd be 1, 2, 3, 4, 5, 6, 7, 8, and if we numbered it from the if we numbered this molecule from the right, it'd be 1, 2, 3, 4, 5, 6, 7, 8, right? So if we're looking at the red numbering, at which carbon number does a triple bond fall on? That would be carbon number 3, right? And at which carbon number does a double bond fall on? That would be carbon number 6. But if we're looking at the blue numbering pattern, at which carbon number does the double bond fall on? That would be number 2. And at which carbon number does the triple bond fall on? That would be number 5. So for the red numbering, we have the triple bond falling on the lower carbon number, right? 3 compared to 5. But for the blue numbering, we have the double bond falling on the lower carbon number, right? 2 compared to 6 for red in terms of double bond. So in this case, we give the double bond priority, not the triple bond. So we would actually choose the carbon numbering pattern in which the double bond falls on the lowest carbon number. All right, so we wouldn't choose the red numbering pattern because the triple bond for the red numbering pattern falls on carbon number 3. However, the double bond for the blue numbering pattern falls on carbon number 2. So we choose the blue numbering pattern, not the red. So knowing the correct numbering pattern, we can now name this molecule. So this molecule is 8 carbons long, so that would be oct, and we have a double bond at carbon number 2 and a triple bond at carbon number 5 and a methyl substituent at carbon number 7. So if we name this, it would be 7-methyl, and because it's 8 carbons long, this carbon chain it would be oct. But then we have to be careful, and we can't finish off by saying octene because we don't just have a double bond, we have a triple bond now too. So first you name you indicate where the double bond is. So it'd be oct dash 2 dash, just the E and the N. So that's still, it's not ene, it's just the E and the N. Okay, so En and then dash, then you indicate where the triple bond, which is the 5th carbon, and then you actually write out the full suffix, which is YNE, ine. So the full IUPAC name of this molecule would be 7-methyl oct dash 2 dash En, so ene, but it's not with the last E, dash 5 dash ine. Alright, and let's move on to the next example now. So in this example, let's do the same thing and number the longest carbon chain. So if we started from let's do both possibilities. So let's start from the right side first. It'd be 1, 2, 3, 4, 5, 6, 7. And if we start from the left side, that would be 1, 2, 3, 4, 5, 6, 7. Now, if we focus on the red numbering and the blue numbering, right, if you notice one thing, starting from the right side for the red numbering, the double bond falls on carbon number 2. Okay, so let's note that. But if you start from the left side, so the blue numbering now, the triple bond falls on carbon number 2. So that means, so what we have to decide is which way is the correct numbering pattern. Do we go from right to left, the red numbering, or do we go from left to right, which is the blue numbering? The answer is that the double bond gets priority in this case. Okay, so the double bond gets priority over the triple bond in this case. So knowing this, let's put the correct numbering pattern on here instead of the incorrect one. So this would be the correct numbering pattern. And now we can go and name the molecule. So first we need to know that we have an ethyl substituent off the 4th carbon. So let's write that down. We have an ethyl substituent off the 4th carbon. And then we can just view the fact that we have a double bond on the 2nd carbon and a triple bond on the 5th carbon. So knowing this, we can actually name the whole molecule. So start naming it from here. 4-ethyl. And then how many carbons long is this carbon chain? That would be 7 carbons, so it would be hept dash, right? And then at what carbon is the double bond on? That would be 2. And then at what carbon is the triple bond on? That would be 5. So this is the full name, right, according to IUPAC rules of this molecule above. 4-ethyl hept 2-en-5-ine. Alright, let's move on to the next example. So again, let's name the longest carbon chain. So if we started from the left side, that would be 1, 2, 3, 4, 5, 6, 7, 8. If we start from the right side, that would be 1, 2, 3, 4, 5, 6, 7, 8. And if we look at both the numbering patterns, if we look at the red first, the triple bond falls on carbon number 2. Right? But if we look at the blue numbering pattern, the double bond falls on carbon number 3, right, for the blue numbering pattern. And so if we look at both of these, if the triple bond falls on a lower carbon number as compared to the double bond, if you're numbering from the other side, so what I mean by that is if we're numbering from left to right, the triple bond falls on 2, carbon number 2, which is a lower number than carbon number 3. If we were to number it from right to left, the double bond would be carbon number 3, and 2 is lower than 3. So we choose the carbon numbering pattern in which the triple bond is the lowest, or falls on the lowest carbon number, which would be the red carbon numbering pattern in this case. So knowing this, right, the correct numbering pattern for this molecule, we can immediately name this molecule now. So what do we have? We have a 7-methyl substituent as our substituents, and that's it. So if we start naming this, it would be 7-methyl, and then again, how many carbons long is this molecule? That would be 8, so it would be oct. And at what carbon number is the double bond on? That would be 5, so it would be -5-en, indicating the double bond is on the 5th carbon. Last but not least, at what carbon number is the triple bond on? That would be 2, and you finish off with the suffix -ine. Alright, so the full name, according to IUPAC rules of this molecule above, would be 7-methyl-oct-5-en-2-ine. Alright, moving on to this last example, let's again number the longest carbon chain. So let's start from the left side, that would be 1, 2, 3, 4, 5, 6, 7, 8. And if we number it from the right side, that would be 1, 2, 3, 4, 5, 6, 7, 8. Now if we pay attention, for the blue numbering, right, starting from right to left, at carbon number 1, on carbon number 1, we have a chlorine substituent. But for the red numbering, on carbon number 2, we have a triple bond. So do we choose the blue numbering because we have a halogen substituent on a lower carbon number, right, because 1 is less than 2? Or do we choose the red numbering because the triple bond gets priority? The answer is we choose the red numbering even though in the blue numbering, the chlorine substituent is on carbon number 1. And comparing that to 2, of course 1 is less than 2, right? Because on the red numbering, the triple bond falls on the 2nd carbon, as compared to the halogen substituent falls on the 1st carbon for the blue numbering. Now, even though that's true, we still choose the red numbering because the triple bond always takes priority in this case, okay? Even though it's on a higher number, which is 2, compared to 1. So in this case, we should take away that the triple bond takes priority in terms of naming this molecule. Alright, so now that we know this, let's name the actual molecule. So let's number it the correct way, right? which is from left to right, because a triple bond takes priority, not the halogen substituent. And knowing that will help us name this molecule. So we have a triple bond on the second carbon, and then we have a halogen substituent off the 8th carbon. So we have an 8 chloro group. So what's the name of this whole molecule? So first we list out the substituents, right? So it'd be 8 chloro. Then we see, okay, where do we have our triple bond? That's at the second carbon. So that'd be dash, 2, dash, and then how long is our carbon chain? 8 carbons long, so it'd be octyne. And the suffix is -ine again because we have triple bond. This is one correct way, right, according to IUPAC rules, to name this molecule above. But as you guys already know from our previous videos, we can also name this molecule. So we would say 8-chloro, and then instead of designating at what carbon number the triple bond is right here, we can go on with the name and say oct, and then say 2-ine. However, me personally, I like using this way in terms of this case right here because I don't want to write two vowels right next to each other like here, but this is still a correct way to name this molecule above. And that's it for this video and naming alkynes in general. I think we have a good idea now of how to name alkenes, alkynes, alkanes, cycloalkanes, cycloalkenes, and now we're going to start talking about functional groups in our future videos so that once we're done with talking about functional groups, we can start practicing naming the common functional groups, right, in actual larger compounds. And then after that, we'll have a good foundation in order to start reactions. All right, so I'll see you guys in our next video.